Writing the recipe is the first step, but without visualizing it, Grasshopper will feel a little bit confusing. So in this video, I'll be showing you the second step on how you can visualize things before you start working in Grasshopper. Let me share my screen with you. Let me put this into viewing. So before I touch Grasshopper, I do this. I sketch. Why writing alone is not always enough? Because when you write these steps down, it's great. It will give you some clarification, but the relationships should be visually connected by you so that you can control the components in Grasshopper. And when these connections are vague, the definition becomes messy because you don't know what exactly you need and you don't know exactly how to utilize them. In that way, or from this point of view, sketching helps you to see the flaw before you build or start building anything. But what does sketching mean from this point of view? It doesn't it doesn't have to be pretty. It doesn't have to be technical. It just needs to show you the flaw, how things will be working out in Grasshopper. So what is the input? What changes it? And what comes at the end? Again, to demonstrate this, I have a simple example. Create a row of facade pins that rotates based on the distance to an attractor point. So this is what we're going to do in Grasshopper just in a second. And here's the recipe. Recipe is already created, so I'm not going to take your time with this. So the recipe that I created is first create a grid on the surface, explode each square, select the top line, select the start point of that top line, add one attractor point, measure the distance from each square centroid to the attractor, use that distance to rotate the top line from the start point, and rotate each fin. And to show you how sketching would work in this sense, I would like to stop my screen share. You see my camera. So I just tilt it down and let me start with this. Let's say this is my surface, okay? I try to remember as I go in. So this is my surface. I divide this surface into smaller pieces, okay? As if I'm creating a grid. So now we can think each of these are my cells or kind of facade panels. To understand the relationship a little bit better, I create a callout for this and have maybe 6x6 pieces. Then explode this, take this line and find a starting point. Let's say this is the starting point. Then based on that starting point, what I would do is I would rotate it with the addition of my attractor point somewhere, okay? So each fin will be affected by the motion of this point all over the place. This is the sketch that I have. Now let's execute on this sketch. I'll be sharing my screen now. So this is my Rhino screen and you already see my surface. By the way, if you want to get free access to the exercise files, follow the link in the description and join my free school community. So I'll get the surface first, set one surface, create a grid on that surface. Then I go to Math tab. I'll grab a divide domain and then I'll go to surface tab under util. I'll grab isostrip. So I connect this here, which will give me, as you see, some smaller surface pieces and explode each cell. To explode each cell, I go to surface tab again, deconstruct VWrap, connect this to here, and it gives me the faces, surfaces, edges, lines, vertices, points of these small pieces. And I get a list item to be able to extract the edge that I needed. Now, all these edges are selected from the bottom. So if I create a slider between 0 and 3, I can connect it to here. And you see this is 0, 1, 2, and 3. So 2 is the one that I'm looking for. I'll get start or curve ends component, endpoints with another point container. I'll grab the start points of each line. But in this case, we see that starting points are this, so I can preview this off, and I can go to my perspective view and maybe set object display mode, and I can make this, just simply go and make this wireframe. And I can have these kind of rectangles maybe. And if you remember, my next thing, so I select the start point, add one attractor point. Now I'm adding this as my attractor point. Import that in, set 1 point, and the next thing, measure the distance from each square centroid to the attractor point. I'll get the area, I'll get the distance, okay? Area and the distance connected here. So what I'll be using a rotate component to rotate my lines, and these are going to be rotated from my plane. So I'll get an XY plane connected here. Just to visualize it, I'll grab a radians component, connect it to here, and let's create a slider between 0 and 180. This will take each degree and turn it into degrees. And you see now I have this. Maybe 180 is too much. Come over here, make it 90 just to make sure it works a lot better for me. Connect it over here, have it here. And the next thing that I wanted to do is to be able to use these distances as my rotation values. So I'll remap them. If you remember my previous video, so I'll get these to be remapped. I need my bounds, and I'll connect target domain, which changes between 0 and 90, and copy this and paste, put this here. And then if we take all these lines and flatten them, all these planes, flatten them, if I connect this angle here, now what I started to see is whenever my attractor point is there, basically rotates a little more, a little less, and so on and so forth. Then what I can always do is to take this line, take that line, and loft them. So I can use merge here, which will help me. So I merge this, right click, simplify, take this and craft this time and simplify. So I have two curves on each, and now I have my loft surface. And if I preview everything off, and if I turn this on, now I have my rotated fins as I move my point in this equation. So if I go back to my Google Doc, so this is how I created my sketch, and that sketch basically helped me to guide my visualization in Grasshopper before I start putting things on the components. The logic becomes visible before Grasshopper. This is very helpful. The definition becomes easier to build. And again, if I see any problem or if I see any missing step, I can always go back and Google things. The structure is also becomes easier to debug. As you saw, whenever I have a mistake, it's pretty easy and clear to be found. And at the end, I stop guessing. I just follow the plan. I just follow the plan. So it goes back to our framework. Write the recipe, sketch the logic, and build the system. If you are serious learning in Grasshopper, follow the link in description. Book a call with me so that we can discuss if I can help you. And I'll see you in the next video.